if I haven't expressed it, I want to express one last time. Like, effect systems are fucking perfect. Promises are junk. They're straight hot garbage. Programming is in this sort of this local maximum that is hanging around in, and there have been better ways of programming that have been sort of embraced in these niche languages, which were too weird to sort of penetrate the mainstream. And bless Michael Arnaldi for bringing effect into TypeScript, because it has allowed it to be viable. Every language where an effect system was introduced in, it did become the dominant way of writing in that language. Never before has it been introduced into something as ginormous as TypeScript, but I feel like we're on that hockey stick growth curve.
Hey Kit, I'm so excited to finally have you on the podcast. We've been planning this for quite a while. It's finally happening. Welcome.
You finally caught me. I guess I have to be here now. What an awful day in my life.
So for folks who probably have seen one of your videos, by now they have recognized your voice and you're finally here. For those of you who don't know who you are, would you mind giving a brief introduction, who you are, what you have to do with Effect, and what you currently do?
Yeah. Hi, everyone. I'm Kit. I don't always sound like this, but I'm very close to my microphone. That's the trick to ASMR. You just get really close to your mic, by the way.
And if you go back, you kind of sound normal. It's my normal voice.
But yeah, just get close to the mic, and it'll all work out for you. My name is Kit. I've been a long time effect system fanatic. It bit me around, 8 years ago. And ever since, I've been doomed career-wise to live in a increasingly diminishing niche of irrelevancy and functional perfection. To sort of build a cocoon around myself and die in it was my fate. But then the robots came, and I got scared, so I decided to flee to the very welcoming giant tower of TypeScript. And turns out there's like nice people there, and there are the jobs and stuff. So luckily I've been saved from my doom fate. So I'm a big effect systems fan, big effect fellow, like effect systems of all kinds, but effect is the first one that seems to have a shot at mainstream relevancy. And I want to curse the world with my same disease. Yes, that's it.
Yeah, so if anyone hasn't checked out Kit's videos yet on YouTube, definitely check those out. We're going to put those links in the description. But aside for your interest in effect systems, you're also currently working on OpenCode. So how did that come to be?
So I think that was a direct. I'll have to ask Dax. You'll have to have Dax on at some point. He's been, I think at this point, thoroughly effect-pilled, as they say, by himself too. I've learned my lesson. I think I might have the record for rewriting the most systems in the world into some form of effect system, just because it's niche enough of a technology, and I've done it at like 5 jobs now. So I've had enough experience trying to convince people, and you can lead a horse to water, etc. I mean, you can really just sort of dump water all around them and make it so that they can only step in water. That's kind of my technique. And just like drink the water in front of them and say, water, so good. This water is pure. But you can't make them drink. So that technique seems to have worked with Dax. Even though I think he wanted me to join because of, he knew what he was getting, rather. I wasn't hiding my effect passion on the timeline, as it were. And so I think I came across this timeline with... I made this thing called effect.institute, which is sort of an ASMR effect tutorial, interactive tutorial thing that's kind of weird. Yeah, I know we wanted to make this interactive, so I could show off some of these things as we talk about them. But,
yeah, I mean, you've now mentioned it a few times. Let's take a look. And for those of you who are just listening, definitely check out the link later. Is definitely worthwhile your time, particularly if you're rather new to Effect. Effect has always been like mind-blowing, but it took a little while until it kind of clicks if you're new to Effect. And Effect Institute lowers the bar so much by like just making it much more accessible. It reminds me to like some of the feelings I had when I tried out like Rails for zombies back in the days. And I was always hoping there would be something like that for Effect. And then Kit came along and did it.
Yeah. I did love Rails for Zombies. Yeah, the goal is to make it such that you would want to go through it even if you don't know what effect is. Like even if you hate effect, you'll want to still interact with the website. So yeah, this is my newest effect tutorial. I have some real feedback here. I'm a wizard. That's wow. It's really great. I have the mandate. Yeah, I have the mandate. That's my goal, is to have the mandate. As you can see, there are lots of many pending lessons here. A little effect or die reference at the bottom. But yeah, I'll just click on this thing. It's so I made my screen ginormous, or my display resolution very low. But yeah, it's a sort of interactive thing. I'll just click through this. You see, you use the arrow keys to navigate between these different lessons. And when you hit space, you will hear my voice speaking to you in maximal narration mode. Welcome to the Effect Institute. I'm Kit, and I want to teach you effect. But first, the briefest of tutorials. Pressing space, as you may have discovered, will play or pause the See, it just paused it. So you can see that there's some animations that sync to the narration. And it's more interesting. You can also command click between sections. When we call it, a promise has but one value. Check out fail. And if it does, so I'll pause it there. Can you hear that, by the way? Is that too loud?
This is, perfectly audible. And I would encourage everyone to check it out by themselves. Probably even better audio quality. You can play around, see those like amazing detail, both not just visual details, but actually also audio details. This is just craftsmanship at its finest. So it is almost so good that it distracts you from learning it.
That was the goal, is to find that boundary. Yeah, and there's some nice animated effects. This is the last thing I'll show off, is that there's some like nice little pretty things that are animated with web GPU, which I'm pretty happy with. Anyway, yeah, I'll leave that for the viewers to indulge in.
And so Effect Institute is built sort of like as a sequential project for some of your previous related work. Let's just dive in, and we'll talk about OpenCode in a moment. But Effect Institute is sort of like a successor project that builds on top of like visual effects, visual types, etc. Is that the way how I should think about it?
Yeah. I've basically been building the weird visual. We can tie this in, I guess, to my weird history too. But I joined a boot camp. That was my entry point into programming, and then they hired me. So from day one at my job, I was always doing some amount of teaching and creating visualizations, because I found that to be fun. Like I went to school for illustration, and so I like to keep some sort of visual elements and build full stacky things. I like it all. I just want to do all of it. And a good way to force everything into every project is to build, some kind of full stack animated application, which kind of lets me shove all my interests in there as best I can. So that's kind of why everything takes on this kind of shape. Actually, back in the day when we'll get to this a while ago, but I started my effect system journey in Haskell and then quickly ended up in Scala. And there's this library called Zio. And you can see right away that this looks terribly ugly. But there's this thing I made, which is this visual Zio animation. It tries to teach you Zio and give you a sense of how things work, help you build an intuition with some incredible animations. Obviously, this looks like hot garbage because I made it in 2019. But, it is working, and it's using Scala.js. So it's actually running this effect system called Zio in the browser and letting you visualize various things. There's some things at the bottom here that don't look as bad. So there's this, visual stream implementation. So if you map over a stream, multiplying it by 2, you'll see sort of the resultant stream is double the first stream. If you zip a stream with an index, you'll see it zipped with its index in the list. So there's some ideas here that are not too different than what I end up doing later on. It's just, I think, generally much uglier. Got a little bit. It turns out if you make a bunch of projects, you get a little better at visual design. So I made that about, a long time ago, this library that Effect was based on called Zio. And then around almost exactly a year ago, Effect became impossible to ignore, and Scala became increasingly, to me, felt like I was increasingly irrelevant in the world at large. So I decided to jettison and at least try. Actually, it was simpler than that. I just wanted to try out Effect, and I thought I could remake this project basically in Effect. So I made a visual effect. So if you go to effect.kitlangton.com, and you'll see it's prettier. Then you get this little spinning orb up there. It's pretty nice. And basically you click and you see a visualization of different effect syntax. So these are sort of the basic constructors. Effect can succeed. It's green. There's sound effects. They can fail. It's red. There's sound effects. And then it can die. This one's fun. So yeah, I definitely got carried away with everything. I'll skip off to some
and just for time reference, I think you built this one pre-AI, or like this one was probably like Claude Code or whatever was not as widely available.
It was. This was a year ago. It was definitely AI helped, but also this is like the architecture I kind of poured. I've just been pulling code forward from all those past projects. So
you could certainly not one-shot this, and so there's like real artisan, handcrafted love going into this.
There is some handcrafted love, and I think you can also bring, as a very brief tangent, I'm sure everyone's seen on the timeline, much slop in the world. People use AI to just build more, and that's great. But I feel like to really take the most advantage of AI, you should use it to iterate even more and to push things further, instead of just letting you sort of poop out more content that just sort of meets the minimum bar of legibility of sort of, okay, this vaguely feels like a blog post that might have been published 10 years ago. Well, now everyone can do that. So there's all this slop. And I think people are getting a little more perceptive around identifying it. There was definitely a time where you would be rewarded for publishing slop blog posts, but I think that that's sort of the telltale indicators of AI. I mean, it's always changing, right? Purple gradients, different fonts, like it's adapting. But if you view a lot of stuff, I think the general consuming public, my hope is that they become perceptive to that and seek sort of higher taste content, higher quality content. And you as a person who's making stuff has more opportunity to iterate further and further. So even if you're using AI to do things, just like raise your bar a lot. And really, because if anything looks off to you, just shoot off another prompt and make it better.
Isn't it amazing that we can now go the extra mile with like so little energy we need to put into it? I think for perfectionists is like the best time ever.
Yeah, and I think maybe the only countervailing force there is that there's also this newfound pressure to produce more. So it's like, okay, I could perfect one thing, or I can produce 100 awful things. So I mean, it's the same balance that's always been there of like explore and exploit, except maybe there's increasing pressure from the outside. But yeah, I'd say it's more satisfying. Like you can explore more, but when you finally do find something that interests you and titillates you, that you feel like there's some promise there, definitely go deep on exploitation.
So speaking of promises, let's zoom out a little bit. Like, highly recommend to anyone, like, check out those various projects that you've just demoed, in case you're just listening to this right now. But you've about, when was it, like half a year ago or so, and we're recording this at the end of April, you've joined the folks who are working at OpenCode, or on OpenCode. I think Anomaly is the company behind it.
Yes. It's not just called OpenCode, but yes.
I think you've joined them with the goal to free them of the promises and bring in effect to the OpenCode code base. So I think there's a fascinating story behind this that I would love to unpack and learn more about. Like, OpenCode is probably a pretty sizable code base, probably even larger so by now. But can you share how big it was when you joined and what the situation was like?
So actually, I don't know. I should know the number of lines of code, especially because I'm sure I've added to it with my various tests and parallel implementations of things. But actually, it can kind of be nice when you're taking off maybe a potentially infinitely sized task to not look ahead and just sort of let the passion of the moment. If you're going to, let's say, run across Antarctica, you might just want to focus on the next 10 footfalls instead of the entire breadth of cold, harsh, alien landscape ahead of you. So I didn't really consider just how much, once I started converting it to effect, how large that task would be. I joined, I think, in February, so it's only been a few months, but it feels like a few years for various reasons.
On a high level, how concluded is the effect migration, the effectification of OpenCode at this point?
It's getting really, really close. I currently have a sort of a parallel implementation of all the routers. So a little bit about OpenCode's architecture is that, well, for anyone who doesn't know, it's basically a Claude code like, except it's all open source and it works with all different models. You can use it with your ChatGPT subscription, your Pro subscription. You can just OAuth in there. You used to be able to use it with your Anthropic subscription, but they took that away. So they've been reducing what you can use that for. But nonetheless, and we have some subscriptions, etc. But generally, it's an open source agent, which, you ask it code queries and it runs in a loop and can call various tool calls and work with all these different providers. And it's open source. And I think the distinguishing mark architecturally is that it sort of is this client server model, so that you can have multiple sessions, you can have multiple clients all connected to the same server that runs the sessions. And there's been some recent work now. We're sort of working on this control plane, so you can have one running control plane and then possibly different workspaces running in different sandboxes, etc. Nonetheless, client-server architecture. And so there's the server, is the point, is what I'm trying to get to. And initially, this was written with Hono, which is a nice server library, very efficient, but it's not written in Effect. And Effect has its own server library. And one of the beautiful things about Effect is that it is this sort of all-encompassing ecosystem that's all very high quality and interoperates with itself, obviously, more smoothly than another non-Effect library will. And there's a couple of reasons for this and why you might want Effect to wash over everything slowly. Not that it can't interoperate, but just the more land mass it claims, the happier you become, because you get to preserve those invariants that it has throughout larger swaths of your code base. And another sort of piece of glue in Effect is the Schema library, which is, if you're familiar with Zod, it's sort of the Zod of Effect. So you design your data as these descriptions, these specifications, and you get serialization and deserialization for free and other various things, because your types are sort of described as data very, very clearly. It can also be used to generate many things like OpenAPI specifications, servers, clients, etc. And it is all very type safe. So once you switch over to Effect, you probably are also going to want to design all of your data models using Schema, and do all of your data modeling with Schema, and also use it to generate your server and open API docs. So some of that was done with Zod and Hono. So I've just gotten the point where there's a parallel implementation of everything using Effect server, the Effect server set up the HTTP API in parallel with Hono. And I have a feature flag that either routes to the Hono implementation or the Effect implementation. And if this works well for the next few days, I'm going to delete the Hono stuff. This is actually definitely a worthwhile tangent, which is, how do you approach even organizing such a migration? So I started off really timidly. Dax did mostly give me the thumbs up. I guess I've been working on also in parallel this other project, which will probably be revealed in time. So that's kind of what I spent my first month working on, with some parallel commits to the main OpenCode code base. And the original intention was actually to not necessarily involve Effect there, because it's an open source library, because maybe that would alienate certain people, just keep it basic TypeScript. But I didn't even have to convince Dax. As I mentioned, I just kind of tried to really make a show of how much I enjoyed working with Effect. And I wanted to make this other project a sort of a shining exemplar of Effect, and let the quality of that sort of incept the idea of using Effect everywhere. But he was, I guess, doing some parallel exploration and using it in some side projects, and ended up convincing himself before I ever had to try too hard. So before long, he was like, you know what? We'll just Effectify everything. I know how these things go. It'll come here eventually. We want it too much. So once I was given the green light, I started very timidly by just porting some identifiers. So one thing that Effect has is with Schema is the ability to have branded data types, and that's very useful in a code base like Effect, for instance. Like OpenCode, you have many identifiers for sessions, for messages, for workspaces, etc. And many of these are strings. They're like random UUID strings, but the type system says they're all strings. And these are passed around everywhere. And the trouble with just using raw strings is that you could easily sort of mistranspose them and pass in a name, like the model name instead of the model ID. And TypeScript won't care. And maybe this will even get serialized and saved to your database, and things will just kind of break in weird ways. So I've always been a fan of using the type system to help reduce the burden of and the possibility of having these kinds of simple errors. Like types are really good at tracking, sort of coloring data in various ways and making sure you don't use put the square peg in the round hole. Simple stuff like this. To add one more tangent to the stack is like my meta thought about AI and what's good for agents is, and maybe this is just selfish in my own worldview that I had previously, but I think it applies, is that what is good for humans is good for agents generally. What is good for a hardworking engineer is also good for an agent, because we're both context constrained. Agents are obviously context constrained in their windows. Nowadays, they have like million context windows, but still there's some kind of degradation that happens beyond 300,000 tokens and lots of them. And I don't know, it's always, I'm sure it'll get better. But for the time being, and maybe until the singularity in the event horizon, I think that will hold for a while. Why not be more context efficient? We obviously, as humans, are even more limited with our primate minds. There's this paper, which is like the magic number 7 plus or minus 2, which is like we can hold basically 5 to 9 discrete ideas in our heads. And we have all sorts of clever tricks of like chunking over time. 5 discrete ideas collapse into like one idea. Driving a car at the beginning is like, oh my God, I've got to articulate each of my limbs in this particular position and put the pedal on the gas to accelerate. And I feel like I'm doing like QWOP, if you've ever played QWOP. Everything starts as QWOP, basically. Let's find QWOP. I'll just play. It's an athletics game. So you have different buttons. Q, W controls the thighs and the calves. So your goal is to start and then I died. So I made it 1.3 meters. And like, we could just do this for the rest of the thing. I used to be okay at this game, but I haven't played this in decades. I'm going backwards. So you can figure out different techniques, but yeah, I'm going the wrong way. Can I even kill myself here? Anyway. So this is how everything feels at the beginning. All skills to me. But it's eventually it sort of collapses, it chunkifies and becomes walking. I don't know why I'm going into this learning psychology stuff. I was interested in this in the past when I was doing teaching. Nonetheless, we still are constrained dramatically. So what helped me and why I was so drawn to type systems and Haskell originally was I started with Ruby on Rails, which is great and fun, but I felt this like deep anxiety building every time I wrote any code. It just felt wrong and scary. Basically, you have to keep everything in your head. There are these implicit contracts that you're dealing with. Otherwise, your code will just break at runtime. So there are always types. It's just whether or not you encode them in the type system or you just kind of use conventions and try to keep them in your head. I don't know how I ever kept it in my head. It's impressive. And for people that can use dynamically typed systems, like I think maybe there's some kind of brain atrophy that occurs when you go over to a static type system because it just feels like so impossible. Once you've embraced that crutch or exoskeleton or whatever, that Gundam, Neon Evangelion suit or whatever of the mind, it's super addicting and super fun. So I just kind of got addicted to expressing more and more in the type system with the goal of enabling local reasoning, which is basically, to me, what all of functional programming is for. There's lots of people who like to get a little onanistic about it. And I think a lot of people like the words like endofunctor and monad and profunctor optics, and they can use these words to confuse and stultify people. We are not going to use the M word because it's actually kind of simple, really. And that word does not help. Like, you don't need it to teach people, obviously. In fact, removing that from effect, people are learning way more effect than they ever learned the Haskell effect system or some of the other more category theoretical embracing effect systems of the past. Not necessary. And in fact, it can be an obstacle. I think people can fall in love with that and it's kind of arbitrary. And anyway, that's a whole other talk. I forget which stack I'm on now. But oh yes, why context? Like, it allows you to forget more and more incidental complexity. The reason why we like pure functions is because it's input mapped to output. You can forget about global state. The second you have global mutable state or even a mutable input, you have to know now in your head, you have to load into your local RAM how everything is called. How instead of just being able to sort of zoom in on this one function, clear your mind, and just solve the hard problem of what you're dealing with. But yeah, I mean, there's so many related ideas there. But generally, to close one of those loops is that we're context constrained. The agents are context constrained. type systems are great for both of us. I'll trust an agent's code if it type checks afterwards, just as I would trust my own code more if it type checks afterwards. If it were a dynamically typed system and the agent made a bunch of changes, well, I would be very afraid. Just as I am with myself. I couldn't work on just JavaScript code bases because you don't refactor a JavaScript code base. Like, that's a horrifying proposition. But if you have types constraining you, you kind of can get to the point. I know it's been a meme and people make fun of, like, if it compiles, then it works. Not necessarily. There's still logic you can get wrong, of course. But if you're just doing a pure refactoring, I'm much more confident that it does work if it compiles afterwards on either side. And you still wanted to double check everything, of course, but you can express a lot in the type system. So that's useful. And even further, Effect allows you to express even more in the type system and have more constraints and a whole bunch of other features. But basically, it allows me to use agents a little more maximally than I would otherwise, to embrace them more and to be less afraid. And also, like, there's two sides of it too. Like, there's the fact that, if it makes a bunch of changes, it probably won't break anything if it does compile at the end. But also, once you have a type, you know certain things about it, especially with Schema. Like, there's an aspect of there's a principle or property known as being correct by construction. If you only expose the limited ways of constructing a type, that might fail. It's sort of like if your types are basically parsed, you know that once you have an instance of that type, certain properties are fulfilled, which means I don't need to, if I have just a string, I don't need to peruse the rest of my code base to know, like, what kind of string is this? What kind of properties does this string hold? I'll say, oh, it's this type. Therefore, I know it's a valid UUID, or I know it's a positive integer. So you just have to search less. There's more semantic meaning in a very specific type than there is string, which can really be anything, which means less context for me. Also less, like, AIs know how Haskell works and how type systems works and how effects work. So they can also trust the type system. So it also helps them not have to, once again, like, look at the whole code base to understand any one aspect of it. If it is sort of pure and self-contained.
Okay, so we're basically just exploring how constraints help overall, and how this has this, like, almost emergent positive effect for any code base. So that's what you've used to start the migration. It's not necessarily that this is the core of Effect yet. It's just that this is a primitive that the Effect ecosystem provides. So you've used that to kick off the Effect migration. What was the next step after that?
Yes. So I got increasingly gluttonous with my PRs. Once I sort of got enough confidence to that I wouldn't break everything. So I made a few PRs. The first two, I was like, oh, please review this, everyone. Review this one-line commit. In short order, I was merging, 20 commits myself, 20 PRs myself at the same time. So all the guardrails kind of flew off once I was not breaking production for a few weeks. So yeah, I sort of started with one service after that. So I did some IDs, fine. That was good to have. Changed throughout the code base. Pretty minimal, just I think an increase in code quality. But after that, it was time to actually sort of make an Effect service. I think that's a reasonable boundary. One of the reasons I like Effect is because of, I wrote an article about this at some point. I think I just posted it on Twitter, my only Twitter article. I was trying to win $1 million, but I didn't. Not enough people care about layers. But just kidding. Services are beautiful because they are very regular. They're fractal. They can express many things. It's a very reasonable module of a code base. And ideally, why I was first drawn to Effect systems, particularly in Scala with the Zio library, is because there was a way of writing code where every piece of your code was sort of self-similar to every other piece of your code. Services were composed of services. It was turtles all the way down and back up. And all the files were easy to navigate. Like, it just felt clean and organized. And whatever kind of OCD I have that only applies to code was deeply satisfied by that particular architecture.
And so an analogy here might be for those, the most of us, I guess, who haven't done a lot of Scala in the past. But I think a more common analogy would be maybe React components, where you've used the word like fractal or self-similar. When you look across like a large React code base, like everything is a React component, and then you compose them together And like whatever React component you look at, you have an intuition for like how the entire thing works. And I think the same can't really be said for like free-form TypeScript business logic, particularly when it's async, etc. And I think what you're describing with a service is there we get that sense of familiarity and composability, etc. Is that right?
Yeah, yeah, especially contrasting it with just vanilla TypeScript. I mean, I'm not too experienced in vanilla TypeScript code bases. I've sort of avoided that like the plague for a long time. Like that's why I was a Scala engineer. So I tried to, live in my own little perfect bubble as long as possible. But I have some, I read about it in books, what the real world is like and how it's very messy. And I certainly peeked at some code bases and was sort of mortified and horrified and disgusted and repelled by the standards that exist out there. Because basically, without effect, you have a few ways of doing things, and none of them are very good, especially if you want to test your code. I think the number one, the obvious way is just to have a file where you implement your service as a bunch of exported functions. And if you have some shared state, just put that in the file. If you start up some connections, just to external resources, whatever, open up a WebSocket connection, just do that in the file when the file loads. I don't know. And if you want to test it, basically, I think if you either don't test it or use monkey patching, like if you want to depend on a service that depends on something else, well, it's importing it directly. So the only way to really test it is to do some kind of monkey patching thing, some kind of mock, which is very brittle and not type safe at all, as far as I can tell, with the tools that I was using or exploring briefly. And so you have to just make sure if you change the underlying logic of that dependency that you also update your tests. And it's easy for these things to drift and fall apart. Which once again, like the anxiety comes flooding back in. The second, like if I on my tombstone, maybe the word single source of truth is what I'll get as my epitaph. It's not a good epitaph actually, but it sounds deep. But that's what I find myself. It's like that's my North Star design principle. Because yes, there's just one way of expressing things. It's and once again, dynamic types fails that test because there are no contracts; they're implicit. So every time if you try to do duck typing, there is no single source of truth of that contract. Every type, you just need to sort of manually make sure that you don't fuck that implicit contract up. With a type system, you can have a trait, you can have an interface. That's the single source of truth for the structure of that type. Similarly, the reason I like schemas is there's a single source of truth for the structure of so many things. Everything is derived from that initial specification, servers, clients, etc. And so with services, you have an interface that represents that service, and you can have multiple implementations of that, which are described by this data type known as a layer, which is a sort of effectful constructor for a service interface. And so you could easily make a test fake, a high quality test fake that, does everything you could possibly want it to do per data type. Sometimes they're very simple. Sometimes you could do more complicated things. In the effect code base, in the OpenCode code base, one of our services is obviously the LLM service, which wraps at the current moment AI SDK. But we don't want to test necessarily against real LLM providers. And every time we run our tests, we lose $100. That would be bad. So one of the things I did is built a really nice test fake library where the rest of you could just run the main sort of session service and call the prompt method on that, and it'll run all the real production code. But when it gets to that LLM service, it's feeding back predetermined data that you determine in the test. So I made a really nice test mock. So first you can make prompt. It'll obviously block waiting for what would have been HTTP responses to come back in from, say, ChatGPT's model. But instead, on the next line, I can say, LLM.text, what's up? And then that will get fed back it'll sort of be streamed in as the response to the session prompt service. You can do all sorts of really beautiful things that I don't even know. My theory is just people just don't really do it at all. They just don't test it. That seems to be the case. That seems to be why so much software is just I'm trying to think of a better word than dog shit, but that's the one that comes to mind. So I don't know. Have you felt this? I've noticed that like ChatGPT.com, for instance, so often I'll type a message. I want to type a second message. I can't hit the submit button anymore. some stream has gotten lost. And with my effect-oriented mind, I just see like a leaked resource or an unclosed stream. An abort signal that wasn't propagated is most likely the culprit, because that's hard to do right, and you have to do it all the time, everywhere, and be very careful about it. And there's so many sort of foot guns. It's just sort of a golem constructed entirely out of foot guns.
So just to bring this back, we're basically walking through the migration from the OpenCode code base with like pre-effect to increasingly effectified, where you've mentioned that by now you basically have a parallel implementation of pretty much everything that's fully effectified, and you're about to flip this over completely. But I think you're still walking through the early stages of like, how did you kick things off? Also, how did you win the trust of the rest of the OpenCode team to like get on board with this, to change the way at that point status quo way of writing TypeScript to now embracing this?
Yes. Okay. Thank you. Yeah, I'm sort of turning this accidentally into Zeno's podcast, or Zeno's Paradoxo podcast, where we'll never get through the first question. We're going to keep getting halfway there and going off on tangents. But hopefully it'll be a good journey to nowhere. Yeah. So services. I implemented a service. So some tangential service, a new service that involved this other project that I was working on, some kind of service that was logging into that. Dax wrote the original version. Had a PR. I knew it wasn't connected to the rest of the infrastructure, so I basically effectified that, turned it into a service. It went well. And from there, I tried to just hunt through the rest of the code base. I mean, many code bases are oriented as services, even if they're not effect services, even if they don't make their boundaries too clear. Every file perhaps is a module. There's some kind of internal dependency graph that you can track. So I tried to find a good inlet there. And I think, generally starting at either the bottom or the top is good. Burning the candle at both ends can work, but also you can start really anywhere. I tried to find some simple services. I think I can show off some code actually at this point. Not that it's going to be
if it's easy enough to understand.
Yeah. And so it's not.
While we're pulling this up, I'm curious, like, how did you choose that service? Like what I've seen a lot is that people adopt effect really motivated, centered around a particularly burning problem. And like often it has to do something with testing. So I'm curious, what was that burning problem that you were reaching for, like a services abstraction right away? And that is probably also buying you some trust and goodwill from new colleagues who are well aware of this problem and might be skeptical of like new technologies. And seeing it like solve a real problem probably goes a long way to build up a lot of trust and to get the goodwill to do the effect migration.
Yeah, luckily I had some cover because, well, I was hired knowing that I was totally deranged by effect and that there would be no stopping me. So I took that as some encouragement. And then, I was mostly optimizing for something that wouldn't break everything. I think I was more afraid of making, like, I already had enough goodwill and trust to do this. They were already sort of sold in effect. The only thing I could see sort of undoing that was if I destroyed OpenCode for millions of users. So it was more like minimizing the impact, at least at the beginning. I knew the benefits would come and things would become more testable. I think one service I started with, I might be wrong on the order. The PR, it's all open source, so you can track all the PRs if you want and go through the history of whatever 400 PRs I opened in the last couple months. But I think there's permission and question services. So I'll just start with question. So this is like the ask user question tool, right? So I can say something
just
like,
for the folks who are just only listening, we're basically just navigating through the OpenCode code base at this point, and we're looking at a few different modules. I think you're using Z here, and obviously also running OpenCode on the side to get some more information about the code base as we do these days. We don't like look things up ourselves anymore, but we get it explained. And so, yeah, we're looking here at a few schema definitions, which I suppose is related to some of the early work you've been doing.
Yep, exactly. So we're looking at the question service. I'm sorry for the audio people. This might be a little weird, but I'm sure we'll go on many tangents that are more amenable to just the spoken word. But the question service is basically, there's this ask user question tool that I think Claude Code first had, where the agent has a tool call available to you where it can submit questions. And then you see in your UI, in this case, a numbered list of possible answers that you as the user can answer, or you can
It's like a
type
little
your own answer.
form as a TUI.
Yes, a little TUI form here. So I asked OpenCode to ask me a bunch of questions. It's obviously pretty random questions because it has no context. It's a new chat. So it asks me for my current goal, what would you like me to help with right now? I don't know, let's say review some code, so I can hit 3 there. How much detailed, okay, whatever. And then research only, fine. And then I can confirm these results and it'll get those results and continue looping with that. I'll interrupt it here. But the question service is the one that tracks which questions have been answered, the user's responses, and when it's all done. So there's a bit of asynchronicity here, which is always a good place to use effect. Once again, that wasn't the primary service. I wanted to start by not destroying the code base and ruining my credibility. But there is also a little bit of extra benefit here. Something that there's some somewhat meaty amorsely about this with regards to concurrency and asynchronicity. And so at the top, I do have some schemas. So the question option, there's like a label and a description. So I guess that's sort of what is actually, I forget what is indeed what here. I should look at this exactly again. I think, yeah, the answer is what I'm offered.
So we're effectively modeling our situation here. So if you think about this form, we have questions, we have like different options to answer that question, and then we get answers, hopefully.
Exactly. Yeah. And the nice thing is that some of this was already designed, albeit in Zod and raw promises. So I didn't have to think about the design of the system just yet. I'm excited for multiple passes where I can improve things or sort of apply my taste and opinions to the overall data modeling. But my goal originally was like, don't do 2 things at once. If you're going to be refactoring a giant hundreds of thousands of lines of code into a new paradigm, don't also interleave sort of semantic logic changes. Because if something breaks, I didn't want to like not know, okay, was it the effect migration that broke it, or was it my other logical change that I couldn't resist?
Don't change too many variables all at once.
Yeah, that would be very frightening. Need to isolate the variables. As you'll see here, I also, on a lot of these schemas, I tend to use schema.class. Just, I don't know, I like the way that reads. One of the downsides of TypeScript is sort of its general verbosity. This is why I was sort of stuck in Scala for so long, is that you do have to sort of repeat various identifiers multiple times for various reasons. Luckily, and this is another tangent we can go on down the line, is like AI, I think, not only helped Effect adoption, but also, well, yeah, AI for me personally made Effect more feasible. I was such a curmudgeon that I loved Scala's terseness and expressivity, as they like to say, which basically just means you don't have to write a lot of redundant code. It's kind of that single source of truth principle, except even at the syntactic level. Just like you write the bare minimum that expresses the idea. With TypeScript, sometimes you have to duplicate yourself. However, agents make this painless.
Exactly. Like now it's basically, you no longer need to write it yourself. So when you had to suffer twice before, where you had to like by hand write out the duplication, then still read the duplication. Now we only have to bear with the reading the duplication, which is more tolerable.
It's more tolerable, and also the brain's really good at pattern matching. So once this, your brain recognizes, all I see now is just, okay, there's an option thing. There's option. Everything else kind of blurs out in the background. And of course, maybe one day we'll have in our IDEs sort of projectors that can, instead of just syntax highlighting, we can sort of restructure the syntax, because if we're not editing the code, we can just sort of read a simplified projection. We could project this into another language that we like. So I could read this as Haskell or whatever. The Unison programming language kind of has support for this. But anyway, that's not here yet. Maybe that'll never get here. It probably doesn't matter, because this isn't really a pain in reality. I get better at reading TypeScript. But you'll see that each of these does have a static read-only Zod property, because I should probably open source this. I mean, it is open source. It's just all in line. But there's an effect to Zod converter. So there's the schema to Zod converter, because we need this at the boundary for the Hono server. So it can generate its API documentation and parse things.
That's how you basically created this like still lasting bridge between the old world and the new world, where you didn't have to do a big bang migration, but you could essentially still have a single source of truth throughout the migration, but still like feed it into the old system and use it in the new system, or vice versa.
Exactly. So yeah, we have this boundary problem, and general. I mean, effect makes this fairly painless, right? So you need a way from going from the promise boundary to the effect boundary, and then from the effect boundary back to the promise boundary. So you can run effects as promises, and you can wrap promises as effects. So effect.promise it actually gives you an abort signal, which is really nice, even though most people don't use that in their promise code. And then you can call out to some other, AI.generate text, and you can pass in the
signal,
the abort signal as an option or something. And that'll turn that into a promise. And of course, you can also do effect.run promise and take some effect and get back a promise of its result or whatever. Right. So you have to do these at the boundaries. And there's some tricks that you might have to do in a large code base like this. And we can get to that later on. I mean, it's all open source once again. So there's some details there if there is some complexity, which this code base does definitely have. And then I had that same problem with Zod and Schema, though I don't think I ever go from Zod to Schema. Because you have less of these stacks, right? So I just defined the base implementation. I just started at the leave nodes instead of like having Zod, then Schema, then Zod. I started at the leaf nodes and built myself back up, converting to Zod at the boundary so that we could use it in the Hono server. And that's basically, so earlier you asked me before about the Hono server. So I do these days have an HTTP API, but basically both are pointing to the same underlying, at this point, effectified services. This one just calls effect.runPromise basically before calling these things. Or I have an app runtime.runPromise on the effect services, whereas the HTTP API can just sort of yield whatever kind of service I'm using .do thing directly instead of having to run to a promise.
And I think that's like really highlighting one of the most important things about using effect, not in a vacuum where like one Sunday you start a new project and you decide to write the first line of code in effect, and like you're already in that universe. But when you have a code base that probably has like hundreds of thousands of lines of code with like that has real complexity, like everything kind of interwoven with each other. Now you want to maybe you have all the agreement that in a year from now everything should be effect, but how do you go from like today to there in a way where you don't like freeze everything? Now you need incremental adoption. And I think this is where there's like multiple ways to go about this, but interoperability is like helping so much. This is why I think converting an existing TypeScript code base to effect is just making that so easy, is like very far away from, let's say, porting something from Go or Java into effect, because you can still like reuse all the chunky bits of your code as little or as much as you want.
Or say like to use a TypeScript library as well, like to make fun of RxJS more. Like if I were trying to do this, I don't think this would work very well. Like going from promise to RxJS, that might be possible, but it's a very different paradigm. All right, this always operates at the level of streams. Everything is going to be a stream. Not all promise code fits into these one-shot streams very well. It's a weird impedance mismatch to fill out your bingo card. Whereas effects represents basically a computation that might succeed or fail. It's strictly a superset of a promise, basically. And then you have a separate streaming abstraction for when you want streams. So yeah, it's pretty painless overall. There are a few nuances. They'd probably be boring in this context, but I definitely will write something up at some point, or add a chapter to my Effect Institute on some of the more low-level gotchas or details. But I think most of that is only because of some particular patterns that we were using in OpenCode that aren't necessarily even very common.
So if we zoom out a little bit, so this questions module has been like one of the first targets that you've converted and sort of like introduced the effect patterns and prove that this is working. If we zoom out a little bit and like over the course of now a few weeks and months, how did the migration progress? Which sort of issues did, like, at some point you probably started looking into more thorny areas of the code base? I think you've mentioned something that before, that there were like pre-existing abstractions that you had to like translate a little bit more. So which sort of challenges were you facing and how did you overcome them?
Yeah. Well, I'm actually going to have OpenCode here render a little service tree of all the services that I've effectified. Hopefully that will help, because this is just one node of many. The sort of the core of it is definitely the core session service that ends up transitively depending on all of these other ones. And just to sort of round off, like, so at the top I had the schemas, which is great, but then we try to make all the files. There are many ways of doing this, but once again, self-similar and consistent, so that if I have an agent port another file, it's a fairly mechanical process. So at the beginning, and I would recommend doing this. This is the approach that worked, at least for me, when migrating a large code base or doing any kind of repetitive task, is like walk through the very first couple of iterations, the example set, very carefully, maybe hand code them, or at least go through a bunch of iterations until you're very happy with the way everything looks. And then use that as sort of a seed, as a reference point for the agent as you tell it to do other ones. And eventually you can see that it gets to a point where it almost does what you need on the first shot or the second shot. And so, yeah, we're really paying attention to those first few examples, because agents are pretty good at copying and extrapolating existing patterns. So you want to make sure that the data set you're feeding it is really high quality. So
if someone doesn't have that in their own code base yet, would you have any advice for references, what people should check out as maybe pointing their agent to as a reference? Should they just look at the OpenCode code base, or are there other simpler reference apps that you would point people to?
So I did make that effect.solutions website for sort of that purpose. I could briefly share that again. I actually don't think I shared this the first time, so let me just share it. I do need to update this. I think I just did update it for the newest Effect v4. But basically, this is just kind of, I was trying to, with all my effect work, effect tutorialization work, I was trying to hit a couple of different, what I thought of as gaps. One was just to, as I was mentioning before, just like high quality content that would have been enticing even for its own sake, regardless of effect, just to expose it to more people so that they would share it and say, like, I don't even care about effect, but here, mom, watch this. This will be interesting. This will make your brain tickle or something. And the other one was, so the existing docs are great, but they're very encyclopedic. And they kind of start from first principles and it just gets into the details really quickly. I wanted a much higher level view, almost like an almanac or a best practice guide of just like, don't worry about how this works. You can read the docs if you want to know that, or you can ask your agents for this sort of low-level tutelage. But why don't I just tell you what to do? And obviously, that's not going to apply to every situation. But if you're a newcomer, what fulfills the Pareto principle of like, here's 20% of the size of the documentation that satisfies most of what you need. So like, here's basically sort of very prescriptive, organize your stuff like this. And there are many ways of doing this. In fact, in OpenCode, I've changed this. I pull this out into a separate interface, but it's really that's a matter of taste. This is perfectly viable, and I would just recommend being consistent, picking something that you want. And there's a whole bunch of examples in here. So effect.solutions has one take of this, and it also, of course, because everything does, there's this copy agent instructions button. So if you click this, paste it into whatever agent you want, it basically tells the agent how to install a CLI and set up your code base with like the effect LSP server and the right TypeScript settings and how to basically read these docs. That seemed to be the lowest friction way of doing it, just like a copy paste into your agent instead of an MCP or something, which is just more friction at the end of the day. Just like click, copy pasta. People can copy pasta since the beginning of time. So I trust them to continue doing that.
Got it. And so that basically contains all the patterns that are like, Pareto principle style that you might encounter as a foundation, just to get things going. And at that point, you probably develop your own taste and your own like preferences. What is like your Acme Corp way of doing things, and then you can mold it and like tell the agent, like maybe create your own skill file or something.
That's basically the equivalent of my skill file, except as a website and not as a skill. Because I think at the time I made it, skills weren't universally adopted.
I think we were still unskilled.
We were unskilled. But yeah, it's basically I was constantly sending paths to my agents of other code bases where I'd done this. And I was like, let me just sort of collect this into a useful thing that I can distribute both to future versions of myself as well as the general public. And yeah, in there, I basically recommend, okay, always use Schema for all your data modeling because, it's principled, it works well. That's just something I was missing from Scala is just, you could basically define any kind of data in the world as a combination, as a sort of a composition of what the functional programming language people called product and sum types, but it's like and types and or types. Like, for instance, you can think of a Boolean. That's sort of the canonical, most simple or type. It has two values, false or true. But a person might be a composition of, is alive, which is a Boolean, and their name, which is a string. Anyway, and you can have infinite types and all that stuff. But basically, that's these two very simple composable primitives are enough to basically define any kind of data type you want in the world. Like bits are essentially Booleans, right, on or off, true or false, and then you just have a bunch of them ANDed together, right? A byte is 8 of them. And out of that, of course, everything computable falls. So it's definitely powerful enough and simple enough. It's orthogonal. It's got everything I like about API design. Like maybe one of the top principles of good APIs in my estimation is orthogonality. That you don't have too many things doing the same thing. You can achieve a lot of power through compositionality and orthogonality. And I think just product and sum types are a good example of that.
We're not going to go in a separate tangent of this, but just a call out also for like your visual types project, which like beautifully also like highlights the various goodies of TypeScript on a type level. I think we're gonna like see a brief demonstration of that, but like please go check it out like in your own time. This is like I think mostly decoupled from Effect, but if you I think it gives you like a deeper understanding of like Effect by just knowing the basics of it.
Yeah. So this is just another fun thing. I was, as I mentioned, newer to TypeScript, and there are some details to the type system. So I kind of did this as a little, both to have fun with animations, but also to teach myself types. So yeah, you can hit the arrow keys again to like navigate between, okay, this is the concept of types or sets, which is kind of what I was alluding to. So Boolean is a set of true or false, direction, northeast, southwest. So these are sort of these sum types, these or types. A number you can really think of as an infinite set of ors. So it still works there. Anyway, there's a whole bunch of fancy animations. And where's the Venn diagram? This is my favorite one. But yeah, I'll stop sharing that one. Check it out.
It's too good to ignore.
I gotta
going back to the migration, and I think you're by now GPT 5.5 has given us a good list of like all the modules. We need to scroll quite a bit. So this is the domain of OpenCode.
Yeah. It's kind of it's sort of it's not done it in the nicely nested way that I would have wanted. It's kind of showing each. We have to reconstruct and traverse the graph here. It's just giving us a bunch of edges, basically. Like, okay, agent define depends on plugin, but we would have to find plugin. I'm going to give it one more chance. And plugin depends on bus and config, etc. I want to actually, there we go. So, okay. So there's the main app layer. Let me go to where's the session?
And I think just like looking at this, ignoring which technology this is, we might be writing Rust, we might be writing something else, but I think this gives you, OpenCode is like a complex product and a complex code base, project, etc. And this gives us a good semantic informational overview over like the involved concepts, almost like a glossary page that explains the various concepts, and doing that in a hierarchical way. And like the cool thing is like those concepts now correlate very elegantly, very concisely with effect services that actually give you the implementation for that concept.
Yeah, basically each of these is an effect service. So every file is laid out the same way. And once again, if I do come up with a better pattern, this is a very parallelizable agent happy refactoring where it's like, oh, let's rename all interfaces to something else. Like, okay, I'm exporting the interface as interface. That's kind of silly, but why not? I was trying to think, should I come up with a better word? Like, what should I call this? Well, it is an interface. So why don't I just call it the interface? And it's per file, so it ends up working out just fine. And so yeah, there's always a service, context.service, that has this interface. And then if there is a main layer, sort of a main implementation, which most of them have just one, it's defined here as layer, which all like the way you construct these things, or the way I always do, is at the top you always import transitive dependencies, or sort of yield your transitive dependencies. So these are other services. So by yielding this, we're going to get a dependency on bus service. So we'll need to come up with an implementation of that to provide later. But of course, bus service has its own layer. So we can probably
just to linger on this. And like, if this is the first time someone is seeing this, and highly recommend maybe switching to video at this point, if you're still just listening, the magic that we're seeing here. And I think that's really novel about Effect. At least when Effect started coming out, no other technology that I was aware of in TypeScript did this, is that if you're using one thing, like here, like we're using this service for our thing that we are building, now we know like A requires B to be. And like this transitive dependency, like that just like builds up implicitly without you having to write down, like be disciplined and write all of this down. Like this just composes automatically. I think that's like one of the most beautiful things about Effect. And that's really like through composition, you can break down the complexity of your code base.
I mean, yeah, the agent was fairly quickly able to come up with this outline all by itself. I wonder if this were in the old style, if it would have been able to figure out this exact structure, because it's able to just look at these values and these types directly. Because basically every file also has, I kind of stole this pattern from Effect itself, the previous iteration, just always also exporting a default layer that takes the layer and just provides a good, reasonable default. So we'll see that if this is imported anywhere, which I'm sure it is, okay, so the server, the main server just imports the top level of default layers for everything. And if these have other dependencies, they're going to depend on their default layers and so on transitively. So you don't have to provide everything. Everything defines a default layer, and you basically just use those at the top of your application.
And just to make this a bit more concrete, if you can go back to the place where you're constructing all of the layers and compose them together, this is probably the like routes you probably instantiate somewhere, and then you run the real thing. But let's say we're in a test. Now you might not want to maybe use like the real LLM layer, but now you might want to use the mock in memory LLM layer. And just by switching this out, like you're still satisfying that you need an LLM service, but now you're providing one that doesn't cost $1 gazillion per run, but like one that you can run instantly while being offline maybe. And this just replacing the need for like crazy monkey patching, etc., is like one of the many killer features here.
These data types. I recently added to Zed. If you launch OpenCode within Zed, you see the selected line ranges down here, which is kind of useful. So you get that as context in the thing. And I just wanted to use that new feature, show it off, because I'm happy about it, because I use Zed and OpenCode all the time. So I was missing this. Sort of explain the data types and how they interrelate is nice, because now it has the context sent there and it knows what I'm talking about.
Very handy.
Yeah, so now if I was confused about exactly what it would be, okay. whatever. Is nice. Okay, so but yeah, so the structure of these layers is you yield to transitive dependencies, then you have some internal helpers potentially. These are not part of the public API. And then I always sort of define the public API as effect.fn calls. And the reason for this is that, well, you give it a nice little label here. This is used as a telemetry span. So one of the cool things we got working in OpenCode is if I go to this little local thing I have is I made my own little TUI for looking at traces called motel. And so I can make this larger or smaller. Let me make it larger.
Okay, yeah, let's look into this. And like before we go more into this, just for those who've like hearing about OTel or OpenTelemetry the first time, it's basically if you're still just console logging and like you're tired of just like looking through like pages and pages of like console log, like, and you want a more structured way, like typically your code runs in a hierarchical way. And this is probably also the way how you're thinking about this. OpenTelemetry is at this point, like a pretty long established common standard that allows you to define things called traces, logs, and metrics. Effect natively integrates with all of this. And it can be emitted anywhere. It can be emitted into Datadog or Sentry or wherever, like all of those technologies support that. But what Kit has built here is a version that runs completely locally and that gives you a much more intuitive way to see what has your complex program actually done and why is it so slow.
Yeah. And so one of the things, obviously before Effect, that we did have some log files, but lots of things weren't logged and you don't get spans. It's actually really difficult to do, I think, OpenTelemetry integration without Effect. I guess I've never tried it before because I'd imagine it would be
not
difficult.
Just only difficult, it's very gross because you have like the happy path. So like the thing you need to care about with OpenTelemetry when you want traces is you need to wrap everything in little things called spans. And that then you can have like in the same way as you have a function and in that function you call other functions, etc. And sometimes they run in parallel. Now you have a little wrapper thingy that is language independent and that's called a span. And where you have subspans, etc. Now you need to basically wrap and instrument your entire code with like spans. And that's okay for the happy path, but you also need to consider things like error handling, or you need to consider things such as like interruption, etc. And this is where you just like keep wrapping and wrapping and wrapping your code until from like a single beautiful functions, you have now 4 layers of brace indentation. And you just like either you regret doing this like OTel instrumentation because your code is like no longer readable, or you do it and you're like you hate this entire thing either way. And with Effect, you basically get it for free.
Yeah, all you have to do is just wrap your functions with effect.fn, which is nice to do anyway, because it sort of is an alternative to the other way you would have to wrap it. I mean, you have to use generator functions to compose sequential effects anyway. So all you have to do in addition to that is basically just add a little label here. And that becomes a telemetry span. You can see that they're nested because if a function is called, if a annotated function is called within another function, they get nested to their current parent, and so on and so forth. And you can see how long these things take. The prompt takes 23 seconds. Most of this time is waiting for the agent to run, and therefore most of the other little things are done at the beginning and at the end of that run. So it's not terribly interesting in this case, but it can be useful to see, okay, what takes the longest? All right, snapshotting takes 102 milliseconds. Is that worth looking into more? Like, is there something that's really slow? I can here sort by the slowest calls. So, okay, why does auth all take 800? So clearly there's some kind of issue with this one because it takes 8,000 seconds. That's not exactly true, I'm sure. A span must be getting left open. But one cool thing is I'm using this to debug OpenCode itself. So every instance I start locally connects to that local telemetry store, this is like totally written in Effect and TypeScript and is all local data. And it's using OpenTUI, which is the TUI framework written in TypeScript that OpenCode uses. Lots of dog fooding going on. So honey making,
and it's probably a great code base to also check out if you want to build your own like effect-based CLI. Effect has a great way to write CLIs, integrating that with a complex system like OpenTUI,
OpenTUI, that works. Yeah, OpenTUI, whatever.
And then also connecting it with like the way how you do state management in Effect apps, which I suppose you're using Effect Atom for this.
For this, I am. Yeah, I've yet to get to the front end, the TUI front end in OpenCode, but one day I'd like to do this. Once the back end is all cleaned up. But yeah, I think this is using Effect Atom. Yeah, it is partially vibe coded this, of course. So I wouldn't necessarily use this as a shining example, but it does work, which is nice. So one of the cool things as well is that if you're running locally, so not in production, you get this session ID. So if I want to debug this very session, I can go here and filter by any sort of attribute key. So I can find session ID and paste this in. And we see there are 5 spans for it.
Yes.
And then theoretically in here, I might be able to find something like a question. Like, let me look for ask, 8 matches. Oh yeah, there's question ask. So I did ask twice. Where did ask
Amazing.
go?
And just to explain what's going on here, we were looking at that like effect code for that ask questions form module in OpenCode, and we've used it before. We filled out like some example data for that, and that code has run. And like in a traditional system, you might have like maybe some log output in a console somewhere, but like then that quickly turns into hundreds, thousands, tens of thousands of lines, and you're just maybe command effing through that. But that gets very boring very quickly. You probably don't have like timing information in there. And here we're like looking at something that is like immediately intuitive. Like we immediately understand where like time was spent, and at every span that we focus on, we now have like some contextually enriched data called span attributes that is relevant for this particular span if we choose to instrument it like this.
Yeah, I should probably add some more attributes for question ask because we don't see the questions here, but that's trivially addressable. One thing that obviously might be striking is that this took 228 seconds, but that's not a problem actually, because if you look at the implementation here, what ask is called
the user
actually
being slow.
Yeah, it was me. It was me taking 228 seconds to finally answer these questions, which is interesting because it shows off a little bit of the effect concurrency primitives that we're using in here. Like this isn't blocking anybody. This is just me semantically blocking and taking a little while to resolve this deferred that was going to be done by me finally hitting submit on those 3 questions. We'll see that it's called question.ask is called inside of tool execute, which is called in session prompt resolve tools, which is eventually called in session prompt dot run. So if I just close this and we can just briefly look at the implementation here, I'll try to do my best to paint a picture. So we have this question.ask function, which is annotated, labeled, which is sort of trivially becoming that span, which just works with any open telemetry provider, including my semi-vibe coded TUI version. Then this takes session ID, a set of questions, and a tool. So these are basically the questions that the agent asks. So this was parsed from the agent's JSON response and is passed into this function. And then there's this tool ID, so we know what tool it resolved to. And then pending. So yeah, we have this, it's a little interesting. I made this instance state abstraction. This is probably one of the more complicated bespoke abstractions used inside of the OpenCode codebase because OpenCode is that server and there might be multiple parallel sessions going on in multiple projects and multiple folders. And we wouldn't, for various reasons, we want each sort of folder to manage its own state. So when you kill that session, we can release all of that state. So this instance state thing is basically keyed by the current implicit session. So each session can store its own list of pending questions, basically. And the pending entry is it's a particular request, and there's this deferred abstraction. And a deferred abstraction is part of effect. It's very nice, very useful for these kinds of interactions, which is something that you can create, and it's a value that you can manually either cause to succeed or cause to fail later on. It's kind of similar to how a promise works, actually, except promise doesn't by default let you outside of the thing complete it or resolve it. But anyway, so it's this value you get that you could store off and later on complete it with a value. So it's really good for these kind of messaging systems where the agent wants to ask the user a question, and then it wants to wait for the user to answer it. So where this is called, it's basically, we call the tool execute calls ask, and then it makes this new deferred, which is either going to succeed with a list of answers that the user selected, or it's going to fail with a rejection error. So this is already like, I kind of was forgetting what this did because I worked on this forever ago. But once again, nice types. These aren't just strings. These are nicely named types. It's like a read-only array of answers, or it fails. And the other thing is that effect obviously lets you signify how something might fail, which is not sort of implicit in promised land. You don't know. You have to look at the values. Here, I can just look at the types and say, oh yeah, this makes a lot of sense. The user either responds or they reject, they hit escape, and they cancel the question. And they're like, I don't want to answer any of your questions, robot. So this is really good as documentation. And then we basically publish this event asked info question, which will get sent to the TUI. So it knows that it's waiting on these questions. And we update this local state, basically saying that question ID has this deferred in it. And when the user eventually replies to a question with a particular question ID here, we can get that state for this instance, get the existing question. And if there isn't one, it'll just fail. It'll short circuit. But if there is a question that it found, it'll delete it from the pending set, and it will publish the set of answers. And then it will succeed the deferred. And by succeeding this deferred value, it allows this bit, which was waiting on for 228 seconds or something, to finally resolve with that success. So it depends on how it's awaiting this deferred. And so it's going to semantically block here. Whatever code is calling this will semantically wait until this deferred is either completed or rejected. And I think there's a reject method as well, which will find that same question and then call fail with a rejected error. And of course, this is type safe. Like I cannot just fail with any error here, because if I change this, I believe this will cause, an error, because this deferred has to fail with rejected error, not with error. So it's all really damn nice. You can't get it wrong. It's nice to be constrained in these ways. I can come back and look at this after, I think I did this 3 months ago, and sort of piece together what it does again live.
And I think what is particularly nice is how it's all scoped locally. Like this is not too large that we could still wrap our head around now walking through this, as most of us are not working on the OpenCode code base and are not familiar with it. Yet looking at this, like we can grasp it. It fits into our head. And yet it's like a non-trivial complexity amount with like all those different cases. But it is all locally scoped. And like we can just compose it like in the overall application, and it doesn't leak out that complexity throughout the entire code base, presumably. But it's all contained here in the same way as if I'm thinking on a high level building something like OpenCode. There's like at some point there's a little thing that's responsible for questions, and then that's resolved, and then that gets out of the way. And I think that maps really nicely to the code, where I like this distinction between existential complexity and accidental complexity, where existential complexity is like all the things that you actually need to build your app. That's the good stuff. Accidental complexity is like that everything additionally gets more complex without adding any benefits to your app. And like that, you want to have as little as possible. And I think Effect allows us to express that at like just the right cutoff point.
I certainly think so.
I would like to shift the topic slightly from like, so far we've been looking at code kind of like the old way, as we've been writing and reading code, etc. And I think that's still important. Like whatever someone else or an agent, etc., is writing, I think us as engineers, we should still be able to somehow load that in our head and make sense of it, and ideally even be able to judge it, whether can it be improved, is it good enough, does it solve the problem, etc. And Kit is having fun over here with like with a Vim mode in Z, and I think it's certainly still worthwhile today to learn Vim as that little anecdote. But what I'm curious about is if we're now allowing ourselves to switch into like a fully AI pilled perspective, where, truth be told, I have written the last line of code, me personally, in October last year, 2025. So since then, every line of code that I've shipped, I have had done by an agent. So I've made the full hard switch, and it's been great. It doesn't mean that I don't read any lines of code anymore, quite the opposite. And I'm more thankful than ever for Effect, because it allows me to review on a much higher level whether whatever was produced here is actually good or not. And I'm also very glad that I've had like years and years of prior hard work, by hand experience, writing all of this by myself. So I know what good or worse looks like, at least judging based on my own standards. And I think that is just becoming increasingly the new reality. Like, not everyone has to go like all the way over there yet, but I do think it's the new reality that it's not just effect being an important thing for humans to decide for, like, hey, are we using this as a team or not? But it also plays a big role whether agents are successful with it or not. So I would like to hand back two questions to you. Like, how much code are you still writing by yourself, by hand, versus with coding agents, working on a coding agent? And what is your perspective on whether effect is an advantage or a disadvantage for coding agents?
Yeah, yeah. Yeah, it's a tricky question, but I'll start by just answering it honestly, which is that yeah, mostly dictating to the agent to write the code for me, even in such sort of embarrassing circumstances as, like, rename that variable or add a parenthesis to line, column 18 on line 149 or something like this. So one thing I do all the time is I made my own open source hex.kitlangton.com. What is this? Uh, I typed that out though. It is sad to see my skills slightly. Like, I miss it, especially in these contexts. I used to do these like weekly when I worked in the Zio world. These weekly videos where I do a bunch of live coding, and it was super fun. And I knew all the tricks in JetBrains and all the refactoring shortcuts, and took great pride in my Vim skills. And I have a Dvorak keyboard layout. I went fully keyboard lifestyle. But of
I have a
course,
split keyboard these days.
yeah, I got my weird double halved
There you
broken in
go.
half. It doesn't even have labels on the keys, which
Oh yeah.
impresses no one, because no one sees it except for my wife, who's not impressed by it. And also, once in a while, if I like need to figure out how to do something with the keyboard, like it doesn't pair with Bluetooth, I need to look at the manual, and it's like, oh, just hit Command Shift Option P. I'm like, okay, but which one's the command key, or which one's the meta key? So I have to pull up the diagram. Anyway, it's very embarrassing in those moments. What was I saying? Oh yeah, so I'm very sad to admit that most of the time I dictate. So I mean, there's tons of apps that do this. There's another good open source one called Handy. I made one called Hex just to fulfill my own specific needs and desires, where I just like basically, let's say, hey, can you delete all the comments I added in this file, please? I want to restore this file. And so I'll just do that. Yeah, it's super fast. It's not me. It uses Parakeet V2 it's an NVIDIA text-to-speech to text model. And there it goes. It left some new lines in, whatever. And with this newfound ability to know what line I'm selecting, I could just sort of, purely with Vim, I don't know why I clicked, I can just navigate between these windows, go to line 135, select this, go back here, hit Option, and say, hey, let's rename the bus variable to vehicle. And it'll do that for me. And then while it's doing that, I'll be able to look around at some other things, and it'll make the change. Yeah, like, okay, maybe I could have actually, sometimes for renames, I will use let me make that back to bus using this trick. But really, if sometimes there are consequences of renaming things where you have to also update it in a comment that the renamer doesn't catch. So yeah, for efficiency's sake, I end up just dictating everything. If you do not yet dictate, I highly recommend dictating, because there is some friction with typing. Like I did my monkey type. At my peak, I had a pretty good words per minute. I'm sure that's atrophied somewhat embarrassingly now, and I have more typos. Luckily, agents don't really care about typos, so you can type like an idiot, and it'll figure out what you're saying. What did I just say? Um, and so, like, you can just degrade even more, even by typing yourself. But there's a bit of a friction there to just typing. Like, it took me way slower to type that. I didn't actually. Oh, I did say it still understands, I think. I don't even. How did it know that? That I didn't. Anyway, I thought I was just devolved into just random letters at that point, but maybe it just auto completed the obvious intention of it. And nonetheless, agents don't really care about typos. So you can type like an idiot. It still understands. Yes. And even there are even some dictation typos, if you will, misunderstandings, but it doesn't matter. The agents get it. Even if you dictate one thing and it doesn't understand how to say, TUI. Okay, 2 weeks. It's not 2 weeks instead of 2 weeks. But if I say, I'm working on an agentic TUI, what do you think? Okay, agentic UI. Okay, fine. So it'll figure it out. And if you're in the right context, it doesn't even really matter. So you can just quickly brain dump so much more context verbally than you could bottleneck through, your digits. As fun as typing is, as much as I miss the experience and the time where that was a sort of a differentiator, I can just brain dump and I tend to have better results. I will sort of secretly, subtly not encode as much of what I'm thinking if I'm typing, because it takes too long and I'm lazy. So it'll be misspelled anyway because my typing is atrophied. So highly recommend dictating. That's kind of my answer. I'm mostly dictating to an OpenCode agent or multiple OpenCode agents. I like to use tabs and have multiple in this project. And another thing I've been doing lately is having it create work trees for different lines of work. Like if I have a refactoring that spans multiple files, I'll just tell OpenCode to create a bunch of work trees. And it doesn't need any special feature for that. It can just create a Git work tree, CD into that directory, and then work there. And then I have it open up a pull request, and then I look at that in the browser. So, make a new work tree where you rename the const bus, select this line here, to vehicle, and open up a pull request. Yeah, and then open that pull request in my browser. So maybe I'll do something like that, except with an actual work task, and then we'll see that it is going to, make some to-dos.
Okay. So that gives us a pretty good sense of your current workflow. As it relates to effect, how do you think using coding agents, etc., how does that compare to working in a completely uneffectified code base? Do you have any comparison there or any intuition?
I mean, unfortunately, or fortunately for myself, I've been so thoroughly effect pilled for so long that I haven't really worked on a non-effect code base in a while. But I mean, I was already, once again, like horrified and recoiled in terror to work on them before agents, just for my own productivity. Oh, something that that slipped my mind earlier, which when talking about the nice constraints of these things, is that if you do not have the constraints of a type system, just like sort of that sort of subtle pernicious tendency to, when typing, anytime there's friction, like we're really lazy creatures, right? We're trying to preserve energy all the time. It takes a lot of effort to be less lazy. Convenience sort of trumps everything. We will express less. Now, okay, just open up the PR for the bus rename there. It's very beautiful. Bus binding is open. So I then would like open up the tab here and review it. Maybe I can leave comments and then have the agent look at the comments. So I'll say in here, I'll dictate, oh, what have you done? Why did you rename this? I don't want you to do this at all. Actually, close everything. So I'll add that comment. And then I will say, read the comment I left and fulfill it. Anyway, it'll do that in the background. So just as if by dictating, I'm able to, I just naturally end up being more encompassing with all of my thoughts, and I don't sort of drop them on the floor because I'm bottlenecked by my typing speed. Similarly, if it is difficult to refactor a code base, which it is if it's dynamically typed, you will just simply refactor less. You might not think that you're avoiding refactoring, but it's a pain in the butt, and it's very scary, at least speaking for me. Maybe some people do love it. Obviously, DHH loves Ruby on Rails, and I get it. Like, there's some beauty there. But for me personally, that scares the bejesus out of me. I just simply wouldn't refactor it very much. I'd maybe like create a whole new code base. And if you're not refactoring, like, why do I refactor? I refactor because I learned something about the code, about the problem space while I'm working on it. And I want to encode that. I want to encode that constraint in the type system, in the structure of my code. I want to delete redundancies, sort of collapse duplication into better abstractions. And I'm able to do that fearlessly with the backing of a type system, doubly, triply so with a library like Effect, which allows me to encode even more in the type system and have even more constraints. So I end up refactoring more, and I end up making more beautiful code bases. So I think that just becomes easier to work on these code bases anyway, because they're better factored and they better express the domain. And I can make them regular. I can refactor so I can shape things similarly without fear. And the more things are consistent, the easier it is for an agent to extrapolate on those patterns, just as it was easier for me to extrapolate on patterns, or like a newcomer. Like, because you can also think of an agent as a fresh, really smart, fresh hire who already knows about, every library in existence. But if your code base is a mishmash of different patterns, how would like a day one, like they're always sort of spawned into existence the second you have a fresh session. I mean, whatever, modulo your agents.md files. How well are they going to be able to perform? The implicit context of your entire code base will guide them even more than the agent's files. So yeah, it's easier to, in a library like Effect, it's easier to refactor. Therefore, it's easier to maintain a higher quality code base that is sort of made consistent. And then agents will sort of extrapolate on that better. And because of this, the regularity, the self-similarity, the fact that each of these files look the same, I could open up 5 parallel PRs, something basic, obviously, and I could sort of scan over it. And just the patterns, if there is an aberration, an anomaly, if you will, that'll be immediately evident just by almost the structure of the code itself. Like one thing I can do is, let's say in here, like I can start from the interface. Basically, I can have I can make it sort of a to-do interface, and I can hand type this if I feel like hand typing it. I could. I'm at this point. Sometimes I actually do mistyping because, and I try to do a little bit to make ASCII diagrams. You saw me do a little bit of that during this talk. I used to do this a lot when I was doing live coding. It can be even more compact sometimes to express things diagrammatically in ASCII. So I might just be able to say like, okay, what do I want? I want a create to do, I want a list, and I want a toggle to do method. So I could do that here, or I could describe it as the interface. Sorry.
No, the way how I think about it is like whatever is like the highest signal noise ratio that you can sort of like give as intent to the agent, like just use that. Sometimes it is like you copy pasting like the old code and the new code. You know exactly how you want the new code to be. Then just write it out, paste it in, say like, hey, let's make this happen everywhere consistently. And sometimes it's like a little a little scribble on like a piece of paper, and like I airdrop the picture into the coding agent, say like, hey, have this idea for this better architecture, what do you think? And like whatever is like the best signal. Like I think the mental model I like is, what if you would show something to your like favorite colleague who's like very experienced, like immediately gets everything without you having to explain everything, and what is the thing you tell them? And I think that works pretty well for coding agents. And that I love the idea of like doing something at the speed of thought. And I think now we can.
Yeah, it's pretty fun. Obviously, they can go off the rails and do all sorts of crazy things. So, like, I don't foresee myself being taken out of a job anytime soon. But I can definitely, by using them often, you get a sense of what their limits are, and those boundaries are always shifting. I mean, I've been using them maximally since they first came out, and the first version of it was called Codex, right? The autocomplete model, and I ran it in JetBrains. I was doing some pretty complicated type level stuff in Scala. And it was able to extrapolate and like I could tab complete and it would do the next arity of the method or whatever, or it would fulfill some pretty interesting patterns that weren't just boilerplate. So I think there is something about the models where they are really good at logic programming and these kinds of sort of mathematical patterns, and they deal well with types, right? I mean, because whatever, the Curry-Howard isomorphism, types are logic, etc. They seem to be pretty good at this domain, and my experience has borne that out. So yeah, what I might do in this case is just, let me maybe I would have just dictated this to make a new effect to do interface, but sometimes it could be fun if I do want to be very specific. I could do this iteratively. Like now that I have this file, I could say, just turn these into actual functions on the interface, please, effectful functions, and we'll see what it does. It should be able to do this pretty quickly. And then once it does, maybe it'll look at other files. Oh, it's loading my whole effect skill, because I do have an effect skill that tells it to look at the effect.
Speaking of that effect skill, is that public?
So there is one in the code base that it found, actually, if I go to effect skill, and it's very basic. And it just basically says, to clone. So obviously, I'm sure you've mentioned this trick before in this podcast, but if not, clone the effect v4. I'm using effect v4 in here. So that's effect-small under the effect-ts org. Clone that somewhere and just tell the agent to look at it.
Right. Yeah. I think that's one of the most reliable patterns, not just for effect, but for like any technology that the coding agents might not be like born with yet. And I think that's a great concept or a great method to embrace. However, I do think that it's still worthwhile pairing that with a skill, particularly to show very specific usage oriented patterns and maybe your preferences. Since like effect is such a wide ecosystem, sometimes there's multiple ways to do the same thing. So for example, if you want to build an HTTP API, you could do it over effect RPC. You could do it over the effect HTTP API module. You can also do it like more low level. And maybe you have certain preferences for your code base. So I think being in the effect skill, making it more yours, being more specific about like, hey, other people might be doing this, but we're doing this here. Like writing this out concisely, I've had good success with for my own effect skill.
Yeah, but it's not, we don't do anything too complicated. It's mostly like agents files. I think the skill was recently added. In the agents file, I do have some basic things like use effect gen, use effect.fn, etc. Like use date time instead of new date. These are some basic things, right? If you see the agent making a mistake a bunch of times, just throw it in your agents file or ask an agent to make that change.
Maybe one other topic before closing out. You've mentioned that you're using effect4 or effect small as it started and still called this way, at least as of today. Did you start the migration with effect4 right away?
Yeah.
Or did you start with effect3 and like upgrade it to effect4 at some point?
No, laissez les bons temps rouler. I just went with it, the beta version. I think I asked Dax. Oh, it was still pretty early on, so I was afraid. I'm like, there's a beta version that just came out. I can use the old version? What would make you feel the safest? And Dax did not flinch. I was like, yeah, just use the beta version. Like, okay,
what's
cool.
your experience with effect4 at this point? Or don't you really have like too many reference points to the old version?
I mean, the agents do great. I think there were a couple of naming flips that went back and forth. Like everything just works so well. I forget what really changed. It's pretty seamless. Obviously, the bundle size has been improved. Tree shaking is improved. Schema is improved. But so far, pretty seamless. I like context.service. I use that all the time. It's better than, what was it before? Context.key, I think, or context.tag.
I think there's context.tag was before and effect.service. So,
cool. Yeah.
Finally, we're going to simplify things.
Yeah, I think this is temporarily service map, but got shifted back to context, which is great because that's a good metaphor from the React world for how these things propagate. I wouldn't even mind just somehow magically having it be service, but this is fine, or effect.service. It's barely noticed that it's a beta. There were a couple of those naming changes, but I think those have mostly landed. It's great. I mean, it's mostly the same API as V3, just better internals and a whole bunch of small breaking changes. But for those methods that were being hit all the time, whatever, the Pareto principle methods, it's not too different of an interface. I can't really recall anything off the top of my head that's dramatically different.
So you've been showing off a bit of OpenCode here during this demo, and I think it really showed off like what a amazing workflow can look like, particularly when paired with an open editor that's integrated now with SED, and maybe also for other editors. Also what you've shown with voice dictation, which I also use heavily. I'm curious what is coming up for OpenCode as it relates to Effect, or maybe as it doesn't relate to Effect. What are you most excited about?
Yeah. So definitely 1,000 different things. I've been mostly working on this effect migration. I did some other fancy things like on the weekends. Now, if you click and hold on the OpenCode logo, boom, makes some different fun effects. There's some other animations I snuck in there on secret screens. We have the desktop app that adds some animations too, but that's kind of being refactored at the moment as well. So I'm excited to get back to some more product work. I did just recently add this Z integration, and my colleague James Long, who is known as the well, I don't know if he's known as it, but I'll tell you, he created Prettier. And he's sort of working on some stuff right now with regards to work trees and workspaces. So you can, I don't think I have this set up locally. It's still behind the flag.
I've seen some demos on X, and like, yeah, I'm a big fan of James's work. I've had him on my other Local First FM podcast quite a while back.
Nice.
And I'm very excited for y'all to have a chance working with James.
Oh yeah, he's great. We just hung out for a week in Miami, the whole team, or most of the team, which was just really fun. But yeah, he's great. You should definitely have him on at some point. You could learn about his effect journey because he's kind of new to it. But I think the pills have taken hold after some time. So he's working on a bunch of stuff with regard to syncing and workspaces that I think it'll make it really nice. Because generally each OpenCode instance right now while there is that server client architecture, if you just run it naively like this, it's kind of all encapsulated. It's serving. It's not even exposed. It's internal to the process. So there is the server client architecture, but it's not necessarily used in this case. You can start it as you can do OC serve and just start it as a server and then connect to this from other clients. Some companies, like I think Ramp famously has built a whole bunch of its internal agentic tooling off of OpenCode using this feature. One thing that I really want to have, and that James's work is going to be a foundation for, is that like basically OpenCode server can be this control plane can be like a daemon process in your computer, and all the clients just go into that. And that'll help with things like memory usage, because instead of having multiple servers, it'll just be one. Similarly, whenever you run Claude Code, like each time it's starting its own server process, and you see the screenshots on Twitter, whatever, of like 27 different Claude Code or OpenCode processes. So that'll be really nice as a user experience, and to be able to sort of switch to different sessions. Yeah, I just want to get back to product work. I have 1,000 ideas. I wanted to first get this effect infrastructure. Like, I don't like refactoring. As I sort of, I think I've expressed a few times, I'm terrified of refactoring non-effectful code or making dramatic changes to it. So once everything is beautiful, perfect, self-similar, fractal effect perfection, then I'll probably make a second pass, sort of embracing, pushing it even further, really making the most out of typed error messages, etc. And then once I'm super happy, I will add a bunch of features. So something I really want to add that I have a few spikes exploring is background background agents and background bash tools. The agent's pretty good at dealing with that anyway, but right now, if I have it spawn multiple sub agents, it blocks the main session. You can get around this with plugins, but yeah, basically making the SDK nicer, and also some of those little paper cuts, like a really nice experience for that. There's 1,000 other things that everybody else is working on, but those were sort of my own little pain points that I want to address after the architecture is crystalline, scintillating apogee of TypeScript. Awesome. Yeah.
I'm particularly excited for OpenCode to be open, like that other people can learn from it, like follow the journey. Now OpenCode is probably like one of the largest code bases that has migrated to Effect or is in the process of migrating to Effect. And I think that gives you a really great like reference how you can do the migration, what a fully effectified code base looks like. And thank you definitely also for that.
Yeah,
leaving off here on a great, cute demo. What are we looking at here?
So my other colleague, Sebastian, known as KMDR, Commander, I call him, because I call everyone by their I guess Twitter handles, because that's what my brain sort of brings into my awareness. Primarily is he added this plugin capability to OpenCode. I mean, it's been there always, but TOI plugins that can also interoperate with server plugins. So when I now prompt it, its eyes will glow. This is Goblin mode. I decided to make a novelty plugin based on the trending meme of GPT's Goblin issue. So this introduced, obviously I said, tell me a story. It injects something into system prompt to tell it to, not shy away from its innate love of goblins and raccoons and such. And then when you're typing, it'll add this little beautiful, it looks like a cat, but a goblin animation here. So pretty stupid, but it's easy to, I prompted this with like 3 prompts and it made a 2E plugin for me. So I think there's a way to get plugins here, and I can disable or enable a lot of the APIs, or the UI is actually built on top of plugins now. So we're trying to make it even more pluggable, which is a fun thing to have. But anyway, I just thought I'd throw that up in the background for silliness as we leave. But yeah, it's an honor to be able to contribute back to Effect and to be part of this thing. I mean, it's if I haven't expressed it, I want to express one last time. Like, effect systems are fucking perfect, and it fulfills the Thelian criterion of being 10 times more powerful and just better than the competition. Like, promises are junk; they're straight hot garbage. Programming is in this sort of this local maximum that is hanging around in, and there have been better ways of programming that have been sort of embraced in these niche languages, which were too weird to sort of penetrate the mainstream. And bless the Italian vampire Michael Arnaldi, the true creator of Effect, I'll say it, for bringing Effect into TypeScript, because it has allowed it to be viable. And one thing I like to think, a little thought experiment, is that every language where an effect system was introduced in, it did become the dominant way of writing in that language. Never before has it been introduced into something as ginormous as TypeScript, but I feel like we're on that hockey stick growth curve. And it's just better. Like, we don't need to really pitch to anybody. We need to like tantalize them with some ASMR shit, but they'll realize either by the quality. I hope to make OpenCode so much better and so much more reliable and memory efficient and fast and delightful to iterate on. As everybody else sort of just uses agents to write JavaScript slop, they'll be weltering in their own slop, and we will be iterating in our golden crystalline palaces in the sky made of pure thought. That's the idea, that we can like really show the proof in the pudding by covering ourselves in pudding and running out into the streets naked, and then everyone will join in the pudding party.
Beautifully said. Well, Kit, it's been a true pleasure having you on the show. We've spent quite a bit of time together, so thank you so much for giving that to me and to all of us here, and sharing that journey, how you came to Effect, how you're effectifying OpenCode, and can't see to see where this goes.
I'm super excited. Thanks for having me, Johannes.
Thank you so much. Take care. Bye.
Peace.
Thank you for listening to the Cause and Effect podcast. If you've enjoyed this episode, please subscribe, leave a review, and share it with your friends. If you haven't done so already, you can join our Discord community. And if you have any questions, feedback, or suggestions about this episode or about Effect in general, don't hesitate to get in touch. See you in the next episode.